If your system is difficult to troubleshoot, this can make your team nervous to modify legacy code or to add additional features. Systems like this take a long time to troubleshoot, or troubleshooting them just doesn't give you the information you need to clearly identify the root cause of issues that you're seeing. So you may have some logs, but they only point to a region of code, and there could be many root causes in that particular region. So it's not clear the specific changes that you need to do. And then you run into digging the hole deeper and deeper, because if there's an ambiguous large block of potential candidates of root causes, you might be tempted to guess and check the fix, and this could actually just create even more issues. So the way that you solve this is you can invest in the following 6 activities to bring clarity and confidence back to your team, to make your system more reliable and maintainable over time. Number 1 is you can improve the logging. Logging is low risk and it can be very high value. So instead of the error is somewhere in this class, it could be anywhere in the 500 lines that this class defined. You can actually narrow it down. This line of code is causing the error. Now we can fix it with confidence. The second thing that you can invest in is types. Here I'm thinking of static analysis types. I'm not thinking of a new object from an object-oriented perspective. Casting in that way can be considered a logical operation, but if we make type hints in Python or TypeScript so that we're improving static types, this represents 0 operational runtime risk in production. So it can improve the developer feedback, it can improve clarity, it can catch errors before you ship to production with low risk. Make sure that these are static types. Don't confuse a new class or data model with a type. That confusion is actually pretty dangerous. The third thing that you can do is validation logic. This is slightly higher risk because it can create errors at runtime, but hopefully those errors are desired and controlled. So once you implement validation logic, then in the downstream logic past the validation gate or guard, you can do things with much more confidence. And also, if you implement your validation logic properly, then you're surfacing informative errors to the consumers. So this can be a win-win. Just make sure that you're not unintentionally erroring in scenarios that you didn't know existed. That's a pitfall with validation logic that can impact your runtime system. The fourth thing that you can do is you can invest in linting. Linting, low risk, and it can improve the readability of your code, developer intuition, ability to reason. You can identify unused code paths, and cutting those out can make your code base simpler. Sometimes what you need to do to improve clarity and confidence is to get rid of unused legacy code or just make it easier to reason about. The next thing you can do here is invest in documentation. Documentation can be a low return on investment activity in many cases. But if you're doing this specifically to understand your system, then it can generate return, and it's really low risk. That's one of the benefits of documentation, is you're not generating runtime risk in the system. The sixth thing you can do is more tests. Actually, these are not in rank order of value. I would put tests before documentation because a good test will improve confidence in your system and it acts as documentation at the same time. So if I were to do this list again in value order, tests would be much higher up, probably even before linting and so on. Tests can allow you to implement the behavior you expect and then verify that the system meets the behavior you expect now and in the future. So every time someone makes a change, you're going to effectively double check that the system is doing what you want it to do. This improves reliability over time, and you're able to read the test so it can improve understanding of the code today. The third thing it does in 2025 and beyond that's actually really underrated is that along with type hints, your tests improve the ability of AI assistants to understand your code base. So the AI assistant can read your feature code, but the tests give a statement about that feature code, which is, this is what we want that feature code to do, which enables the AI assistant to much better catch discrepancies. Previously, it might have caught technical bugs in the feature code. This will literally generate a value error or a type error. But otherwise, it's going to assume that it's working as intended. So it wouldn't surface logical issues. Hey, the code technically won't error, but it's actually not doing what you intend. That sort of knowledge is not available to an AI assistant in the absence of good tests. When you have both, then the AI is super, super powerful, and that'll supercharge your workflow. Okay, those are the 6 things that I recommend. Follow for more.